The purpose of this screencast is to show you how to do part 4 of the model lab on alkenes and alkynes. So we're going to use a website called molview, molview.org. So you'll just agree to these terms by closing it. And because Molville either has a sense of humor or because Molview is really inspirational, they have the structure of caffeine on their opening page. So to give you a little boost, if you will, here's the structure of caffeine, which I think is kind of fun. I'm going to go ahead and get rid of it though, because the first thing we're going to do is ethene. Eth, we know, has 2 carbons, and then it'll have 2 hydrogens because it'll be CnH2n, or excuse me, it'll have 4 hydrogens, CnH2n. So then I can go over to Molview and put in a double bond right here. And so that's all I need to do for ethene. If I go over to where it says CHs toggle for the skeletal formula, skeletal can also toggle between that and our structural formula. So I've got my structural formula. Now that shows 90-degree bond angles and 180-degree bond angles. So, doesn't look so great. They're probably spread more evenly, right? And we know that about alkenes. And so there's a way to look at that in Molview. We're going to go 2D to 3D. And so here is a better 3D drawing of ethene that shows its bond angles at each about 120 degrees. And so then by just clicking on it, I can start to rotate that and take a better look at that molecule in 3 dimensions. So it's just kind of fun, especially as the molecules get more complex, to rotate them around and look at them in 3 dimensions. Now, if we had actual model kits out here, we could look at the CC bonds, and those CC single bonds are usually free to rotate. Think about all the conformations of butane and how we could rotate butane about its central CC bond. But this double bond is just not going to have free rotation. That would be a little bit easier to see with a model kit right in front of you. So let's do at least one more together. I'm going to get rid of ethene. We're going to go on to cis 1,2-dichloroethene. So it's still going to be ethene. It's still going to have that CC double bond, but now there is a chlorine on carbon 1 and a chlorine on carbon 2, and we'll have to fill in with hydrogens. And so if we were writing a molecular formula, it would be C2H2Cl2. And now let's try to go over here and draw it with Molview. So I want that double bond, and then I need to stick some chlorine atoms on there. So let's see. Oops, that replaced it with chlorine. So never mind. Let's try a single bond out here. And we can try another single bond. And now let's go and replace those carbons with chlorines. I clicked on chlorine to replace it after I had created a bond to carbon. I wanted a bond to chlorine, so I replaced it. Now let's see if we go and we use this tool, if we'll be filled. So there it's more structural or line angle, if you will, and that's a structural that gives you the hydrogens. So we can kind of flip back and forth. That's kind of fun. And then we can go over here and go 2D to 3D, and now we see it with chlorines. It warns us that the angles, the bond angles might not be perfect, might not be resolved perfectly, but it is showing us how those chlorines are physically larger atoms with larger radii, and they take up more 3-dimensional space. So that's kind of fun. And so as the groups get larger, you can see what happens in the cis versus the trans conformations. So go ahead and make the rest of these. I'm going to draw this one out with my nice 3D drawing. Putting my hydrogens and my chlorines. I want to make sure my chlorines are cis, that they're on the same side, especially when I show my 3D drawing. My structural formula is kind of showing that they're cis, but really when I'm asked to show cis, this is what I want to do. And so hopefully with this little bit of background information, you can finish part 4 of the Model Lab using moleview.org, and then take a photo or photos of your page or the paper that you wrote all of your answers on, and then go ahead and turn that in as your assignment today. Um, you might have noticed that I struggle not to say Moleville instead of Moleview, because when we're doing stoichiometry problems in general chemistry, I talk about an imaginary town, Moleville. And so I kept struggling not to say Moleville instead of Moleview, and it was giving me the giggles. But hopefully, this is a shorter assignment for today that you can complete and have some time off on your Friday and have a great weekend. Bye bye.